Encrypted Sigma. Now, this is the continuation of the overview why we need to use display descriptive statistics. All right. So this one will ensure, that your results are valid. To consider the following guidelines when you collect data, perform the analysis, and interpret your results. So the data must be numeric, super important. In this part, if it's alphabetized, or it's an ABC, or it's like A, B, or C uses that, then you can actually put that in codes. Like, for example, 1 is to A, like 2 is to B, 3 is to C. Or if you want to, you must have a continuous data such as weight of packages, or discrete data such as the number of complaints. If you want to summarize sample of count data, use tally individual variables. Now, the sample data should be selected randomly. Do you remember the random sampling? This one. So in statistics, random samples are used to make generalizations or inferences about a population. If your data are not collected randomly, your results may not represent the population. For more information, go to randomness of sample of data. Number 3 would be collect a medium to large sample of data. Samples that have at least 20 observations are often adequate to represent the distribution of your data. However, to better represent the distribution of a histogram with a histogram. So some practitioners recommend that you have at least 50 observations. Larger samples also provide more precise estimates of the process parameters, such as the mean and standard deviation. So much for explanation, but maybe we can go ahead and provide you the example of this display descriptive statistics. All right. So, for example, this is the problem. A quality control engineer needs to ensure the caps of shampoo bottles are fastened correctly, right? If the caps are fastened too loosely, they may fall off during shipping, or if they are fastened too tightly, they may be difficult to remove. So these are the problems that may occur, so to the customer or to the manufacturer. Now, the target torque value for fastening caps is 18. That's a target. The engineer collects a random sample of 68 bottles and tests the amount of torque that is needed to remove the caps. Now, as part of the initial investigation, the engineer analyzes the descriptive statistic of the torque measures to assess the distribution of the data from the machine. For example, a while ago we said that at least 50 from your random sampling, so that you can get a good number of data. So, as part of the initial investigation, the engineer analyzes the descriptive statistics of the torque measurements to assess the distribution of the data of each machine. So, we have here number 1, open the sample data. We already have saved that a while ago. Then it's just going to show you the steps. Choose statistics, basic stats, and display descriptive statistics. Just like this. Okay, we're going to click on that, cap torque, and no, we're just going to open it. All right. All right, now we're opening mini tab. Okay, let me just go ahead and adjust the recording here, so at least we're going to get the whole information. So first, let's go ahead and discuss first what we see on the data. All right. The C1 column here provides you the torque, and if you notice, let's go ahead and observe the data first. We have until row 68 for the column 1. But of course, we have the same at 62. So first question, is it 50 and above? Yes. So is this a good data? Yes. All right. Now, let's go ahead and check. It says let's go to stat, and then let's go to basic statistics, and then let's go click the descriptive display descriptive statistics, or DDS. Now, if I hover over the mouse, it says here, summarize your data with descriptive statistics such as the mean and the standard deviation, and display the results in the session window. Let's go ahead and check. Click that. All right. Now, what is your variable? Our variable would now be the torque. By variables would be the machine used. So remember when we studied the machine a while ago, it has 1 or 2. Let's go ahead and check your statistics window. When I click the statistics window, this would definitely show, and you can edit this one by, for example, mean, SE of mean, variance, but you can also put, like, for example, you can want to see the sum, right? You want to see like how many, that's 68. You want to see the number of total, that's okay. What else? You want to see the percentage, that's okay. You can promote whatever you want when it comes to basic statistics. It's all here. Now we click OK. Now we try to see the graph. So you remember we had like 4 graphs a while ago. Histogram of data with normal curve, individual value plot, and box plot of data. If you did not tick any in here, definitely there's no graphs. But what if I do? I click on everything. I click on OK, and then I click on OK again. Okay. Did you see, like, in just like 3 seconds, it showed the descriptive statistics that we have in here. So now the variable is torque, correct? Let's go ahead and double check. The machine is 1, 2. It shows you now the total count of how many, the calculated count for machine 1 and 2, total number, the percentage, the mean of that machine, SE mean, standard deviation, sum, and minimum, and quartile 1, median, quartile 3, and the maximum. Isn't that amazing? Now let's go ahead and check the graphs that we have over here. Now you can use control minimize. Alright, control minimize so that you can see the picture in one frame. So there you go. Let's go ahead and study. On the y-axis we have frequency, x-axis is torque. Alright, and compare the numbers for 1, that's until 36, for machine until 36, there. With histogram with the normal curve, this is the difference, guys. Notice that the curve is there. It is represented by the red curve. Alright, one of the greatest thing in here is that you can see the individual value plot. It is represented by dots. Okay, now you see, try to interpret it as you see it. This is one of the amazing features of Minitab. Once you see the picture, you will then be able to analyze that, okay, in machine 1, the torque is the torque on machine 1 is here from mostly 15 to, I would say, 17. Okay, you hover over your mouse over here and it would show it. But in here, it is more scattered from encrypted sigma. Now, this is the continuation of the overview why we need to use display descriptive statistics. All right. So this one will ensure, that your results are valid. To consider the following guidelines when you collect data, perform the analysis, and interpret your results. So the data must be numeric, super important. In this part, if it's alphabetized, or it's an ABC, or it's like A, B, or C uses that, then you can actually put that in codes. Like, for example, 1 is to A, like 2 is to B, 3 is to C. Or if you want to, you must have a continuous data such as weight of packages, or discrete data such as the number of complaints. If you want to summarize sample of count data, use tally individual variables.
What the sigma? Bro.
What the sigma?